Okay, so here's the first problem. Find the x and y intercepts of the graph of y equals x cubed minus 4x. So you want to think, what is an x-intercept? Well, an x-intercept is wherever the graph will intersect the x-axis. So that means y will equal 0, because another way to say the x-axis is the line y equals 0. So let's set y equal to 0. We'll get 0 equals x cubed minus 4x. Then we can factor out an x from both. So we have x times x squared minus 4. And then you can factor the x squared minus 4, so you'll get x plus 2 and x minus 2. And now you have all your x values at x equals 0, negative 2, and positive 2 is where this curve is going to have y equal to 0. If any one of these factors are equal to 0, it makes all of the others kind of cancels out all the rest, because anything multiplied by 0 will turn everything else 0. So then, usually I like it if you guys name the x-intercepts as points. So let's turn these into points here. So we're going to use the original equation. We're just going to plug in x equals 0. We see that our first x-intercept, and we'll label everything clearly. So x-intercepts, we have 0, 0. Then if we plug in negative 2, we're going to have negative 2 cubed minus 4 times negative 2. And we'll have negative 8. And then here we have plus 8. And actually, this is interesting. What happens here is, look, I don't need to do any work with this, because if I were paid more close attention, then maybe you guys already caught it, that negative 2, 0, any x-intercept is going to have its y-coordinates equal to 0. So then we can just report them and take a shortcut here. And then how about the y-intercept? Well, the y-intercept is going to be anywhere where visually the curve intersects the y-axis, but the y-axis has an equation of x equals 0. So that means that anywhere where x equals, or we turn x equal to 0 and see what our y value equals to get where the curve will intersect the y-axis. So we'll have y equals 0 cubed minus 4 times 0, and of course that's 0. So our y-intercept is going to be 0, 0, and you can see that that's actually one of our x-intercepts too. You could think about why that point is special, why the x-intercept and the y-intercept are the same. Let's do another problem. First, we'll clear the screen away using this roller thing, and then pick a different color. Hey there, Mr. Curry.
I was gonna lock this, but if you're in here, do you have a key to lock the door?
Yeah, I do.
Okay, cool. Thanks.
Alright, thanks. You're making a guest appearance in a video?
What's that?
You're making a guest appearance in a video?
What are you talking about?
Alright, so math video lecture here?
Oh, are you doing that? Oh,
yeah, that's alright. No. Alright, so I want to find the intersection points of the graphs of the equations x squared minus y equals 3 and x minus y equals 1. So both of these equations will yield two different curves, and we want to find out where they intersect. Well, what we know about them is that wherever they intersect, their y-coordinates will be equal to each other. So if we just rearrange the equations and solve for y, and set the two equations equal to each other and then solve for x, we'll be able to get the exact points where they intersect, or point, depending how many there are. So first, let's rearrange both of these. So we'd have x squared minus 3 equals y, and on this side we'd have x minus 1 equals y. And now we'll set the two y values equal to each other, and we'd have x squared minus 3 equals x minus 1. And now we can solve at what y value or what x value the y values are equal, and that's the definition of an intersection point. So let's do a little bit more rearranging so we can factor. We'd have x squared minus x, because we move that x over to the other side. And then we'll add 1 to both sides and get minus 2 equals 0. And now we can factor. We'd have x minus 2 and x plus 1 as our two factors equals 0. And that means that x equals 2 and negative 1. But I like it if you guys report these as points, these intersection points, because they are points. So let's see what points we have. And we can use either of the two equations. If we've done our work correctly, we should get the same answer from both. So let's use this original equation and then the rearranged form here to get what y equals when x is equal to 2. So if x is equal to 2, again we have x minus 1 equals y. Then we'd have 2 minus 1 equals y. That means y equals 1. So our first intersection point, 2, 1. And then our second intersection point, let's see, x minus 1 equals y. So we'd have negative 1 minus 1 equals y. So y equals negative 2. So our second intersection point would be negative 1, negative 2. Alright, and for the last problem here, we'll have my face, and we'll also make it a little bit easier. Or it's a kind of easy problem to finish off on. So it's we have this line, 3y minus 2x plus 5 equals 0, and this point 2, negative 1. And what we want to do is we want to find the perpendicular line. So how do we do that? Well, this line here is in standard form, so we can't easily tell the slope of it. So let's rearrange it into more convenient form, into slope-intercept form. So we'll have 3y equals 2x minus 5. Divide both sides by 3, and we'll get y equals 2/3 x minus 5/3. So there's our line, our original line, and we want to find the perpendicular line that also passes through this point. So if 2/3 is the slope of the original line, then the slope of the perpendicular line would be negative 1 over that original slope, which equals negative 3/2. So there's our slope for the perpendicular line. So we'll use this slope and this point and the point slope equation, which is what you use when you have a point and a slope. I know some of you like to solve for b and use the slope intercept. That's fine as well, but this kind of eliminates one step for you. So here we go. So we'd have y minus 1 equals negative 3/2 times x minus 2. And then we just solve and we get y plus 1 equals negative 3/2 x plus, because negative times negative, 3. Subtract 1 from both sides. We have y equals negative 3/2 x plus 2. Alright, well that's it. Make sure that you know how to do those 3 problems for class tomorrow, and I'll see you then. Good luck.